Okay, as you know, one of the main problems of economics, at least since the work by Lucas, is the macro foundations of macroeconomics. And there are, according to me, at least two ways to interact, to deal with this problem. The first one is the mainstream approach. Usually they use representative agent or non-interacting heterogeneous agents. So there is a sort of fixed population of agents who do not interact except in the market. So if you believe in a representative agent, it's fine with me. You know, there is no Santa Claus, but if you want to believe in Santa Claus, that's fine. I'm not going to disappoint you at your age. And the other approach is the agent-based approach, according to me. This can be divided into two strands. From one side, there is the agent computational economics, and you can find a lot of literature on it. Fashion, we have Gintis here, but also Domenico Gallegati and Doen, and a lot of people working on this stuff. And then there is a relatively new approach, which is called analytical solvable interacting agents, heterogeneous interacting agents. The acronym is Asia. And you can have analytical solution for millions of interacting agents. We have two different approaches. One is the statistical physics approach followed mainly by Foley and Aoki and Thomas Lux, and the other one is a rather new approach followed by Landini, Stiglitz, and other people, and there is also a grant by INET on this stuff. Instead of having economic agents as atoms, you allow the possibility of learning. So there is a sort of evolution, or endogenous evolution of the system itself. So in a way, the main important results, according to me, is the following. Instead of analyzing 1 million equations, you can use just 2 equations to analyze the system. So from the analytical point of view, it's a very huge improvement. The main problem is that if you use the computer, 1 million equations can be solved, say, in 10 minutes. With this analytical stuff, you need a very good, talented mathematician, and he can solve the system in maybe 2 days. I'm kidding. No, I mean, as you know, it's very easy to solve this system. So goes beyond complexity, according to me. The first question is information. If you have perfect and full information, you have no interaction, heterogeneous agents, and basically you can skip the problem of coordination. The problem of coordination brings the problem of pathologies. Of course, if you have representative agents, you have no crisis at all. It's quite difficult that if you have a single agent, unless he is schizophrenic or an Italian politician, you know, he could have some problem in coordinating with himself. So only if you want to understand the crisis and the cycles, and then you have to move to this direction, toward the heterogeneous interacting agents. So according to me, a complex economics is quite important because there is the emergent probabilities which came out from the bottom-up interaction of individual agents. By the way, Gintis offered us a very nice way to deal with interaction and emergence, since he is modeling agent-based according to a Markov chain, very simple or very complex. It depends on how smart you are. But so for me, it's almost impossible to understand what they say. Then for sure we have what Don was saying. You don't need to have large shock to have large effect. A small shock can produce in a complex system large effect. But I don't like the idea of shocks, basically, because beyond this idea, there's a sort of equilibrium of the system. The system is there, is very quiet, unless there is a shock. So in a complex system, there is some dynamic endogenous movement that we can deal with. So according to me, the complexity approach is quite important because it allows us to pass from an axiomatic discipline like economics today to a sort of falsifiable science. Again, I'm quite fed up with the idea of axiomatic discipline. My family is Catholic, so axiomatic it was enough. I mean, religion is axiomatic, and I want to lose my time again in axiomatic discipline. But the passage is quite important because once you are in a sort of falsifiable science, you can falsify the theory or the models at different levels, at the micro level, and then at the meso level, at that macro level. So you have, so to speak, a lot of possible explanation of cluster behavior or other stuff. But if the cluster behavior is explained by a theory unable to explain other facts, we have to reject the theory. It's quite simple. I mean, it's not a big deal. So, going ahead, we have this agent-based approach. The agent-based approach told you is a bottom-up methodology, mainly focused on interaction. And the equilibrium is different from the mainstream equilibrium. There is a sort of statistical equilibrium here. So if you look at this chair, the chair is stable, but this is a macro level. At the micro level, atoms are running somewhere, I don't know, in the chair itself. So, according to me, agent-based is basically characterized by two main elements: the multitude and the fact that there is no central authority. And the real problem is the emergence. We have no theory of emergent behavior. The European Union is financing some people to understand and study this behavior. So, I mean, the problem is there, and we need to solve to go ahead. I'm talking just a little bit about Asian computational economics. Basically, you have a relationship with the computer or a computer scientist, if you are an economist. You model bottom-up individual, very simple behavior and the interaction of the model. Then you can run your computer and see what's happening. As you will see, there will be very different outcome from similar initial conditions. It depends again on the outcome, on the nonlinear probabilities of the system. I would like to point you out that there is a lot of validation going on this stuff, the empirical validation. And according to me, a real problem is the problem of the degree of freedom. We have a lot of degree of freedom in this model. So basically, you can say whatever you want. Asian models usually use master equation and Fokker-Planck equation, or Markov chain, as I told you. They are able to provide a sort of approximation of the question of aggregation. Again, it's quite important that you can solve analytically the system, because you can skip off the problem of the degree of freedom. But this is not enough for me, according to me. So we are now working on this stuff. there's a quotation by Gelman, and the quotation is, you can read, if atoms could think, physics would be very difficult to understand. The problem is that atoms are equal to economic agents only if information is perfect and they are fully rational. So there is just one way to behave, otherwise you are crazy, or as I told you, you look like Berlusconi except for the bunga bunga. But, you know, yeah. Tremonti didn't show up, so I have a question, a lot of questions to Mr. Tremonti, but unfortunately he was not able to come. Yes. So in this case, in this HR2 case, we are in the point of analyzing strategic behavior and learning in this class of model, this analytical stuff. So it's quite important because, according to us, it is very path dependent. There is no equilibrium. You can have a lot of statistical equilibrium depending on where you put yourself. Then some slide, I can, yeah, I can. Yeah, may I say goodbye? Anyway, this is just to show you that if you deal with complexity, you have to deal with network and analyze the eigenbase. Instead of edge being edge, you have agents, and they interact in quite different way depending on their position. If you want to analyze, for example, systemic risk, you have to use this kind of stuff, not the other one, and not the usual one. You are not one policy good for every solution. So the conclusion is that I strongly believe, and I hope that if we will be able to move toward the complex economic stuff, we'll be able to make the change of economic theory from an axiomatic discipline to a real falsifiable discipline or science. That's all. Basically, yeah, yeah.
Thank you very much, Mauro.